Well, hi everybody. Talking to you. Happy Valentine's Day. And if you're not here, you can see it's just a bunch of dudes who are either very longly married and have understanding wives or no significant others at all. But we're here and you're here online. We greatly appreciate you. You can't see him, but Josh Carlisle is joining us all the way from Raleigh, North Carolina. He drove you. So tonight's a milestone night. It's our first speaker from out of town since the before times. And it's also our last meeting in this space.
Oh, really?
Yeah.
Oh.
Because Issue Track is moving to a new space. So we're doing some juggling of our space needs. So
Okay.
we'll be virtual next month and the month after. So you'll be there. So Josh, you're the first person here since before times.
Yeah.
You're also the last person in this space.
And this is also my first public talk since COVID.
Yes.
Done virtual stuff. This is my first public talk.
Wow.
And based on the trending of AI, it'll probably be my last public talk because I'll probably be replaced next month
I hope so.
by some AI.
Yeah.
It'll probably do a
I'm
much
being
better
replaced.
job.
We're all replaced. Talking here to Mr. Chen, and I mean, we're all replaced by ChatGPT.
It's going to be wonderful.
Yeah. All right. So with that said, Josh, I'm going to turn it over to you.
Okay.
Let you do your thing. And everyone out there in the land of Twitch, YouTube, whatever, I have to leave myself. All right. I have to leave myself in the stream so we can hear you. If I take the room out of the stream, we can't hear you. So I'm not going to do that.
Okay.
But we can see your slides now.
Okay.
You're good to go, Josh.
And let's do a quick sound check. Can you hear me and can people on?
I can hear you just fine.
You can hear me just fine. Okay. Well, if you are online and can't hear me, please make a note in there in the comments and they will relay it to me.
Mm-hmm.
Also,
I don't mean to put you on the spot or
Yes.
make you nervous, but Linda Nichols is watching you right now.
Okay, I can't screw this up.
And she's going to correct you if you get it wrong.
That's okay. There'll probably be lots of corrections.
All right. You're all set.
Okay.
I believe everyone can hear you just fine.
No pressure.
No pressure.
No pressure. Okay. So basic rule of thumb here, we've got a small audience, and that means we can make this really interactive, right? I don't have to say, please hold the questions to the end. Please shout out if you got a question. If there's something that interests you and it's not too much of a tangent, let's hit it, right? Let's make this a little bit fun. I will let Kevin relay any questions online to me. Same rules apply for you online too. If you got some questions, please chime in and I'll have Kevin interrupt me because that way we can make this a little bit more fun. So as Kevin mentioned, this is probably my fourth talk at this group, maybe third, fourth talk. Kevin and I were talking earlier about like, when did we meet? And we think we met when he spoke down at Trinug, and I've been quite involved with Trinug on and off over the years. And I think I met him around 2007, 2008 in Trinug, but it's always great to come up here. It's a short drive, honestly. It's great to listen to a few podcasts, and then I'm here, right? And it's always a good excuse to see some faces that I haven't seen in a while. So once again, let's just go ahead and dive right in. So here's the boring part we'll get past. This is the about me. So as mentioned, I'm from Raleigh, North Carolina. I've been living in this world for 25 plus years, right? So I kind of got into this career path circa 1996. I just told the story last week that I was told I need to tell the story again. How did I get started in technology? I saw a student study job at a library for a web developer, and it said JavaScript experience needed. And I went out and bought a J++ book and read it all throughout the weekend and showed up on my first day at the job, really primed for J++. So that was my first experience into this industry. But I've been here for a little bit. I'm also Microsoft MVP on the Azure side. My day job, I'm a principal architect and principal engineer at Zscaler, which is a cloud security company. There's some contact information for me there. Feel free to reach out to me. I'm semi-active on Twitter. I more kind of observe than speak, but I'm always on Twitter. So reach out to me there. I have open DMs or drop me an email. Go old school, right? If you got some questions. But that's some ways you can reach out to me. So why are we here tonight, right? Well, we're here tonight because of that. Distributed apps are hard, right? The world is kind of dominated by distributed apps these days, right? And it's for a reason, right? There's a lot of benefits of distributed apps. But unfortunately, they come with a great deal of complexity as well, right? Architecture, any kind of architecture is always about compromise. And especially so with distributed apps. Distributed apps are all about compromise, right? But why are they so hard? Well, in general, there's lots of reasons why they're hard. But to a certain extent, there's a lot of things that you have to think about and consider and make plans for before you can start really building distributed apps. You know, where and how am I going to host my app? What databases and state stores am I going to need? You know, distributed apps today are full of messaging platforms, a lot of asynchronous communications. What messaging platform am I going to use? Where am I going to store secrets, configuration? Now, to a certain extent, that first section applies to any app that anybody's building, but it's especially more complex when you're talking about distributed apps. But then you got a lot of choices to make about languages and frameworks, and talking about messaging platforms. You could if you're talking about like Kafka, for example, there could be like 5 different libraries for Kafka. Which one should I be using? All these little decisions, right? That all lead up to sometimes decision lock, because you're worried about long-lasting consequences if you make the wrong decision here, right? But also there's just a lot of moving parts, a lot of plumbing. You got to have a lot of expertise in different areas. And so if you were to look at kind of this big blue semi-skewed ball on the screen here, think of that as representing a typical effort for building a distributed app. And unfortunately, the reality of the situation is a lot of times you spend more time than anything else on, oh, that's not working. Sorry, my little mic, my little remote thing isn't working, but on platform and plumbing, right? You spend an absorbent amount of time on platform and plumbing, and the true business value, the problem you're trying to solve, the reason you're getting paid to solve a problem, you find you're spending smaller and smaller amounts of time on that, right? There's some different words for that, and in some spaces they call it toil, and it's just platform overhead and lots of things. But what if I were to tell you that there was a way you could make it look more like this, where you're spending more time on the business value that your application provides and less time on all those things on the right-hand side? That's the crux of why it's important to listen to the next 45 minutes to an hour. Because hopefully at the end of this, you'll go, okay, I understand how this solves that problem. So this is the problem we're trying to solve. At the end of the day, we want to spend more time here, less time here. And that's where Dapr fits in. So Dapr is the Distributed Application Runtime, right? And so what Dapr is at the end of the day, it's a runtime, right? So it is a set of APIs that provide for many of the common building blocks that distributed applications require. Building blocks, things like service notification, one service calling another. State management, essentially database stuff, right? Pub sub, very common. Binding to resources downstream, binding to external resources. I need to, and anybody in the Azure Functions world, has anybody here used Azure Functions a little bit? Okay, a little bit. If you've seen bindings in Azure Functions, this is the kind of bindings world where I can work with some sort of downstream external resource in kind of a generic way. Observability, right? As soon as you have distributed apps, lots of moving parts, it's really, really challenging and a lot of work to kind of get good visibility so that when some of those moving parts don't work like they should, and that will always happen, that you have good visibility into that. Secrets management, configuration. So all these sets of building blocks that are very, very common to distributed apps. These are problems that you will be having to solve for pretty much every distributed app out there. I'll talk to it a little bit more at the end, but Dapr actually has additional building blocks that are coming out in current versions and upcoming versions and roadmap. So this list of building blocks is growing and growing and growing. Now, you notice here I said API, not library, not framework. I said API because this is a runtime. These features are accessed through an API that's available over HTTP or gRPC. Okay, and don't worry, I'm going to unpack this a good bit so you'll understand a little bit of this. These are accessible over HTTP and gRPC. The advantage of having all of this wrapped behind an API is that all of these features are available to any language that can do HTTP or gRPC, right? So Dapr is not opinionated when it comes to language, although we're going to be focusing on .NET today. It's not opinionated about language. It is not opinionated about the platform you're deploying it to. This works equally well on AWS, Azure, GCP, on-prem, bare metal, and I'm not going to talk about this at all, but VMs, right? All of this applies to this. So it's less opinionated from the standpoint of the platform and language target. Obviously, it's an API, so it has some opinions on how you interact with some of these external resources. But at the end of the day, it's greatly flexible. We're going to be focusing on .NET because one of the nice things that Dapr gives to us is a bunch of SDKs. So nobody likes to, well, most people don't like to go raw HTTP. Some people enjoy it, I guess, to each their own, right? But going raw HTTP, although we can do it, it's always nice to have a nice layer of abstraction that can take advantage of language-specific constructs to make life easier for you. Today, we're going to focus on I was about to say Go. Today, we're going to focus on .NET. And we're going to actually use the .NET SDK to kind of show and demonstrate how Dapr works. A little trivia side note is that I've spent probably 3/4 of my career in .NET, not the last 4 years. I live mostly in a non-Microsoft space these days. Spent most of my career in Microsoft space, but in Microsoft tech stacks, and specifically those tech stacks. But I live in Go these days for the most part. And I know I'm an Azure MVP. I live a lot on AWS as well, right? So I am kind of language agnostic with these days. But the interesting aspect of this is that I hadn't done a lot of .NET work in really the last couple of years. Very, very, very little, right? Putting together this presentation, taking it from the Go examples and the general community examples to .NET, it was like visiting an old friend. .NET, it was a pleasure kind of getting back into .NET. And it was a lot of fun putting together this demo just for .NET. So a little bit of trivia there. But so how does this actually work, right? We're talking about this API. Is this like some API that's hosted somewhere on a server and I got to call it all the time? Not really. So what Dapr runs on is this model of a sidecar. Anybody here kind of familiar with sidecars at all? A little bit, okay. So sidecar is a model that is mostly applied to these days. When you talk sidecars, you're thinking a containerized Kubernetes environment. That's where most people think sidecars. And we're actually going to be deploying this to Kubernetes at the before the end of the demo here. But a sidecar is essentially when you spin up a container, it's like a little child container that runs next to it. In practical terms, when we end up deploying this, and you'll see this towards the end of the presentation, this runs in a sidecar. When we're in development, though, we're not necessarily living in a container world. You could do development in Kubernetes if you're kind of into that kind of thing and like pain. But at the end of the day, it's a process. It's a separate process. So you'll see here in a short bit, when we go through some of what the developer experience is, the Dapr runtime is just something we spin up. It's a little process, right? That's hosted on a port. When we deploy it, it runs in a sidecar. So it lives alongside our application. So whenever we deploy a Daprized app, it deploys a sidecar next to it. And that sidecar hosts the runtime. And the nice thing is, once again, you'll see this towards the end, all of that interesting plumbing, you're thinking, oh, I got to deploy this and deploy this. It's all handled for you. Dapr will take care for that for you through its operators in the Kubernetes environment. We'll kind of show what that looks like. And it's actually pretty stress-free to get that up and running pretty quickly. But so the sidecar model essentially is a place where this API is hosted. So at the end of the day, you have your application and you make localhost calls to the API, right? So this isn't hosted somewhere else. This is local host. So think of, if you were thinking of a traditional VM or local desktop, This is just another process that has a port open, right? So you're making local host calls. And those, once again, those local host calls can be done over HTTP or gRPC. And they kind of look a little bit like this. You're calling localhost. Dapr runs on a port, has some default ports, but you can override that. And if you notice here, this is the case of we're invoking some downstream REST endpoint, right? I don't care where it is. Dapr is going to do that service invocation for me. It's going to find out where that lives, figure out how to get to it. All I want to do is just say, hey, I want to call a REST endpoint or a gRPC endpoint that has this identifier and just pass it all this stuff. Same thing with state. Like if I want to talk with state, I want to talk with a database. Same thing with publishing pub subs. I want to publish a message somewhere. So all of this stuff is available through HTTP. There's also gRPC interfaces. And once again, we're not going to go this low level, but it's good to understand behind the scenes, behind the SDKs, that we're doing HTTP and gRPC behind the scenes here, right? But this kind of covers how the app talks to Dapr. How do we get to this outside world, right? You know, a real database, a real messaging platform, service bus, Kafka, whatever it may be, right? It reaches the outside world around something called Dapr components. So Dapr components fall into certain categories. There's state store components, there's pub sub components, there's bindings, there's secret stores, there's observability. These are all different components that we define. Dapr is a fantastic layer of abstraction. It abstracts away working with these categories of components, and the implementation is done by the Dapr runtime. So the Dapr runtime, when we register a component, we're going to say, hey, I want to do pub sub. The actual pub sub destination is defined through the component. I'll show you what that looks like here in a second. But as you can see here, and this is only like a small subset, Dapr allows us to work with lots and lots and lots of platforms for these various categories. I can switch seamlessly, and you'll see this in action here in a second. If I want to, and I want to go from one platform to another, and there's some reasons why we might want to do that beyond just, oh, we made it oopsie, we want to pick a whole new platform. There's some valid reasons why you want to do that under normal circumstances. We can make zero code changes, just register a different component, and the magic happens. It is also worth mentioning, I don't cover this, I'm not going to cover this in detail tonight, but it's worth mentioning that all of these components here, the implementation details, are all community contributions. There's hundreds of them. And they're growing every month. They're all community contributions. And once again, you see, even though obviously I'm an Azure fanboy, right? I like living in that world. You see AWS stuff here, you'll see GCP stuff here, you'll see CNCF stuff here. So it's fairly neutral. Essentially, the community, when they see a need, they add it to it, right? It's worth mentioning that for many enterprises, sometimes you have something that you want to have a special component, but you don't want to share it back with the world. Maybe it has intellectual property, it has whatever it may be. There also is a type of component called a pluggable component. I'm not going to go into it tonight, but it's good understanding that, knowing that it's there. It's basically bring your own component. If there is something that Dapr can't do, I'll give you an example. We use Snowflake at our company. Right now, there's no Snowflake connector. There's no Snowflake component. If I want to build my own and I want to, maybe I have my IP in there, I'm not allowed to share it back. Or maybe it's just still neutral, but our company doesn't let us share it back. I'm not saying Zscaler is like that, but I'm just saying in general, right? Or, hey, I don't want to align with whatever the Dapr release schedule is every month. I need it now. I need it like next week, right? You can actually build your own pluggable component and bring your own component. So you basically implement some interfaces and register it, and it behaves just like one of these components, right? So it has a great deal of flexibility. But how do these components actually get registered? What do they look like? Well, in general, we're going to register our component through some YAML. The world lives around YAML these days, right? So we're going to register our component through YAML. This is an example of working with a Kafka component, a pub subcomponent with Kafka, and I'll call it a couple things here. The kind is always component, right? We define the component. The name is whatever name that we give it. This is how we interact with this component. You'll see this in action here in a short bit. When we run our code, we want to talk to that component. We have to give it a name. Hey, I want to talk to X component, right? So we give it a name. The spec defines what that component is. So this is a pub sub component with a subcategory of Kafka, right? So you'll see here how we're going to seamlessly kind of go between Redis and Service Bus here a little bit, right? They're both pub subcomponents, but they have a subcategory. One is an implementation in Redis, and one is an implementation in Service Bus. And then the metadata is basically all the connection and configuration details that are likely component specific. For example, Service Bus has some connection string requirements. Some of them might have Kafka has 10,000, client configuration pieces. All of that, all of those specific implementation details for working with that component type, Kafka or PubSub, all come in through the metadata. So that's how we can configure this, right? So we define this in our YAML. And this is an example of the .NET SDK. You notice I'm not doing any HTTP stuff. I'm not doing any gRPC stuff. I'm essentially newing up a Dapr client. And in this case, I've created a order model. Nothing too extravagant here, right? Representing an order. So how many folks here have actually done some messaging? Ever worked with any messaging platform? There's usually a good bit of plumbing, right? A good bit of code, good bit of configuration, a lot of different things depending on the language. This is all I had to do to write to the message to a topic. That's all I had to do. And what I'm doing here, sorry, my pointer isn't working, so I'm using version 1 pointer. Is you notice I have PubSub processor here, and this is PubSub processor. So this is saying, use this component and use this topic and pass in the order. All the other plumbing behind the scenes is taken care of for us, okay? And it actually has more features to that behind the scenes, because if you're familiar with kind of the concept of middleware, right? There is a lot of middleware that's available with the Dapr runtime to add some value even onto what's going on here. But this is the component PubSub kind of situation from a high level. We're going to dive into some code and actually kind of see it in action, what it looks like. But conceptually, you'll always be defining your components via YAML. And as in the case of Kubernetes, which is typically the deployment target for Dapr, there are customers out there in the wild running this on traditional VMs. There are customers running it on all the different clouds. But Kubernetes is typically the deployment target. But like I said, this is just a process. So you can deploy to a VM if you want to, right? If you have to go that route. But we're going to dive into some more detail and kind of unpack this a little bit more. But before we continue and dive into more detail on the developer experience and what that looks like, and anybody here, I saw a few hands for Azure Functions. If you're used to like Azure Functions events and bindings, things like this will feel really, really familiar, right? For that. But one thing I do want to call out is it's not just all about the developer here, right? So if there are any folks on the call or here that also work in the DevOps space, the operations side, maybe they're on observability teams, there are some tremendous benefits. I'm not going to go into a lot of detail on them, but it's worth mentioning. Because we have this Dapr sidecar, and that Dapr sidecar is responsible for both incoming and outgoing traffic. At the end of the day, what ends up happening is all your incoming, outgoing traffic, it all comes through your sidecar. Because everything's funneling both in and out of your sidecar, it's a really convenient way to get lots of great metrics, throughput metrics, golden metrics, all the things that you want from a visibility standpoint out of the box. Didn't have to write any code. Request rates, throughput, your error responses, you name it, right? And it's all there by default. So you have some improved metrics and visibility. Distributed traces, because these platforms inherently know that they're going async and they're talking to Kafka, they're talking to whatever it may be, and there's one app talking to another app because Dapr is aware of when it's talking to different apps inside their Dapr ecosystem. It goes, oh, you're about to hop a boundary here. Let's throw a distributed trace in there. Didn't have to do anything, and we'll see this in action. It automatically knows how to inject distributed traces, and it uses OpenTelemetry, by the way, and we'll talk about that a little bit to do that. So you get a great deal of visibility for free. Because of all that, you get a lot of consistency in your environment. It's very common in enterprise spaces. When you have lots of microservices, they all kind of have their own little variations, right? And they can become a little bit challenging from a support standpoint. So there's a lot of consistency. Platform flexibility. I kind of alluded to this a little bit, but as I mentioned, you can take one component, and as long as it's in the same category, pub sub, I can swap out Redis for Service Bus, for Kafka, without making any code changes. Now, that becomes important for some considerations, especially if you're new in your environment, you're new building out your app, and you're like, I'm worried about making a horrible decision here, right? And that decision is going to haunt me, right? This gives you a little bit of flexibility. So if you decided, for example, hey, I wanted to go a Kafka route, and Kafka isn't, I find out a year later, this isn't a good fit. Kafka clusters are really hard to maintain. This is too much. I want to start using something fully managed, right? RabbitMQ managed. I don't know, something like that, right? You can make that change. There is a story there. That's an important story. It reduces some of the decision lock when you're building on a new application, gives you some flexibility. That's not actually the most interesting thing. The most interesting thing is locally, think about a lot of distributed apps. When you want to spin up the whole environment, you have to have lots of dependencies installed locally, or you're connecting to other resources externally, right? You can actually spin up, and we're actually going to do that tonight, resources that are cheap, inexpensive, low overhead for lower environments and local environments, and use different ones for production environments or pre-production environments where you actually want to validate the infrastructure, right? We do this today in our infrastructure. We're heavy into DocumentDB, for example, AWS. We pay for DocumentDB. It's basically Mongo, right? In our lower environments and local, we just use a Mongo container, right? In some environments, we even go even lower and say Redis. I don't care. I don't need any local storage. I don't care that I lose everything when I spin down my container. I want a really, really lightweight container that I can run on my Mac. It doesn't take up a bunch of overhead. My coding's the same. When it deploys, it's on Mongo. When it deploys in production, it's on DocumentDB. When it's local, I'm on Redis, and it's all the same, right? So it's very often the case that you want to have some variations on your environment for cost-saving measures, for overhead, for simplicity, things like that. And this allows you to do that. The last thing I'll make mention of is the resiliency. I'm only going to talk about this a little briefly, but I mentioned middleware a little bit, right? Because we have this runtime on the side, we have the opportunity to do things in that runtime, right? And one of the interesting things that we can do is set up resiliency policies. And those resiliency policies allow for things like retries, exponential backoffs, circuit breakers, all the things that require a good bit of effort to do in your own code that you get transparently with any downstream resource. So I can create a policy and I can tweak different policies and say, apply this policy to downstream HTTP calls, apply this policy to pub sub retries, apply this policy to gRPC retries, register the policy, and I get all of that, once again, for free. So I get a high level of resiliency in my microservices, which are arguably super important with microservices, right? To have a good bit of resiliency by being able to register these resiliency policies and just apply them to any kind of chatter in between services, right? So these are all things that DevOps and platform teams love, right? Because it basically means a more resilient platform with better visibility, easier to support, and flexibility with deployments. Those are all things that those teams love. So keep that in the back of your mind. I'm not going to go too much into platform stuff, but it's a big win. It can be a big win for teams. So ready for some demos?
Yeah.
Okay. Enough talking. Well, I'll keep on talking, but enough talking with PowerPoint. Okay. So let's switch gears a little bit. So first off, how do you get started from a, ooh, look at that. That's psychedelic, isn't it? So how to get started. I am not going to go over like how to get the local development experience running, but it is quite simple. Dapr website has great documentation, lots of great examples. They do a really good job at it. Hit the getting started guide, pick your platform of choice, and install the Dapr CLI. Simple as that. I'm on a Mac. I went to Brew, installed the Dapr CLI. Depending on your IDE, if you're in the Visual Studio Code world, which obviously a lot of folks are, we could take that one step further. So we're actually going to do everything in Visual Studio Code. to kind of help out our development experience. Once again, I'm not going to go into the installation of Visual Studio Code and go to Dapr extension and install it, but I will kind of go through how it works. So I'm in Visual Studio Code right now, and I have an extension installed. And no, I'm not going to do an update because that's just, demo gods would probably have something to say about that if I do an update now. So we can see we have that Dapr extension, right? And what this does for us essentially is give us some good hooks to have the F5 experience. This is really just all about the F5 experience, right? And so what I've gone and done ahead of time here is, and actually, let me just talk about, and I missed this, let me just talk about the use case real quick. I kind of lied a little bit. I have one more slide, I'm sorry, but it'll help line up what we're about to do here.
I'm done. Get off.
I know, I just ruined it for everybody. So this is what we're going to do. So this is not the epitome of distributed systems with just one talking to another, but we can extrapolate this concept and kind of go further, right? We have a .NET service that takes in an HTTP endpoint, right? And then that request, we want that request to go into a pub sub, right? And when it lands in pub sub, we want to save the request somewhere, right? Pretty simple, order request, order processing, right? Pretty common use case, right? For local development, because I don't want to have the cost of the cloud right now for my local development, and also because I want to go lightweight. I don't want to install Kafka locally and go through all that headache. I just want to use Redis because Redis is so easy just to work with, right? So for local development here, we're just going to use Redis as our database, as our state store, and use Redis as our pub sub component. Okay, we'll show how we can vary on this theme. And so this is our use case right now. So as I open up the code here, I want to call out something briefly here. Once again, there's a good intro on how to use the plugin and kind of how to wire in things. But at the end of the day, it has, when I've set up through the command palette and said, hey, initialize this guy for Dapr, what it's done for me is it's created a bunch of tasks. And you'll see here, here's an example. Oops. We stopped sharing because it's not showing the screen here. Sorry. That's better. Okay. So this is just a task.json. It's the normal stuff. You'll see we have some extra properties in here. We have the type of Dapr. So this is telling us that this debug start is going to initiate this Dapr piece. That's part of what the extension runs. I've passed in some arguments to that. The app port, the HTTP port, the gRPC port. The app port is the port that the runtime talks back to your service from, because the pub sub has to tell your service the message came in, right? That's how it all works. So this gives the ports of how things talk. And this gives the instructions to the Dapr runtime to start up for us. So this saves us the hassle of having to go to the Azure CLI manually and starting up a Dapr runtime instance. It basically takes care of it for us. The other important piece here is this guy right here. So when the Dapr runtime starts up, it needs to know what components you're using, right? So I need to point it at a components folder. When we're in the Kubernetes world, it's actually all handled. There's no actual physical folder anywhere. There's some other aspects of a deployment for Kubernetes. But in this particular case, we need to give it a path to our components. So if we go ahead and start looking at a little bit of our code, look up here. Let's go to the order API first. So the first thing you'll notice is that we have a components folder, and I have defined two components, pub sub component and a state store component, right? And this pub sub component has the name order pub sub, and it's of type Redis. And the state store component has a type of state, and the type is Redis. Now, behind the scenes, when we do the Dapr CLI install, there's an option for it. It actually installs a couple of Docker containers for us, which is really helpful. You don't have to use these, but I lean into these a good bit. So if I open up my local Docker instance here, and it's a little bit small, but you can see here that I have a Dapr Redis instance right here, right? So that holds on a pub sub and does the state store stuff for me. So I've got a container running here, a really lightweight container running Redis here locally, right? If you don't want to use the one that Dapr gave you, you can install your own. Yeah, question.
Oh yeah, so the Dapr CLI handles grabbing containers and configuring them for running.
It will do, when you do a Dapr and NET, it knows the common needs that every developer will need on their local desktop to kind of get started. And so it will initially seed your local environment with a Dapr Redis instance for you.
Okay, so we can go through the YAML for all the different types of stuff and grab the container it needs.
No, it won't do any container loading for you. So if I change this to Kafka,
Yeah.
I would have to make sure that I have a Kafka instance running locally on my machine in a container, and I had all the settings right. It tries to make the initial developer experience really seamless to kind of get started up and running quick. The most seamless path for most of this stuff is Redis because it's such a lightweight, it's easy to work with. And so the Dapr and NET will automatically create this container for you. If you want anything outside Redis, then you're on your own. You have to spin up whatever you want locally. A lot of our teams are just using Redis because you can use Redis for those. Our two big state store and PubSub are two big distributed app use cases. And so we generally use Redis locally because it's just so easy. But you do need to be aware that there is Redis running here in a container, right, behind the scenes. If I go back here to, so I have two components defined. Those components will get picked up when I run the project here. The other thing I want to call is my source. Now, this particular project is just a minimal API. And by the way, I hadn't seen minimal APIs since I've been out of the .NET space for a couple of years. Pretty cool. They're definitely not enterprisey, but if you just need to get something really quick up and running really briefly, especially for demos, or if you're like in Node world and you're used to like a single page with a function on it, it's kind of compelling. It definitely has its place. I use a standard web API in the other example, but I thought it was a little bit fun. So this is a minimal API. And all we have here is, and once again, this is pretty straightforward. I have added, if we look at the, what are you hiding at here? You notice I have a reference to the package Dapr.client. So I've added this package reference for Dapr.client. And I have, and all I have here going on here is, and let's minimize this here. Is this big enough for you guys? Is this, okay. Yeah. So all I'm doing here is basically bringing in a model, right? And I'm getting some of the component names out of environmental variables because I have some stuff stuck in configuration. This is not Dapr specific. I'm pulling configuration from environmental variables. And as you saw earlier in the code example, that's all I have to do to submit this, right? That's it. So this is actually a post orders endpoint. So we'll grab this here in a second, right? And we'll actually see this in action here in a second. But this is all I need to do to get something into PubSub. I take the model coming in from the post, coming in from the request, and I make sure I'm referencing the proper PubSub component. I could have hard-coded the string in there that has the PubSub variable name, the PubSub component name in there. And the topic that I want to talk to, I have an orders topic already deployed on this thing, and the order model. So let's see this in action. Let's see what happens when we hit play here. So I'm going to go ahead and run this. Now, the first thing that you'll notice, the first thing that you'll notice here is if we go down here to our output, my screen is so shrunk, I got to find things. There we go. Terminal. You'll see that we have this terminal over here. And so what happened is Dapr, because this is a Dapr extension, it automatically spun up the Dapr runtime for me and automatically wired in the component loading. So all of this stuff in here, and this is one of the things the only thing I don't like about the extension is when I do this through like old school through a console, I get all the color coding. I can see stuff better. Everything in here is just like verbose. So it's worth mentioning I have this in debug mode right now, so it's spitting out a lot of stuff. But if we scroll up here, we can see some different things going on. We can see metrics server starting up. Remember the metrics I was talking about. We can see, I'll do a quick search here. We can see the PubSub component being initialized, right? So we can see it's loading up all these details. It's read the component directory. It's loading up all those details. And it's loading them up. So now it knows, the runtime knows the components it has to deal with. It now knows. So that when I go ahead and if we go and switch over here just quickly to Postman, and and I'm running in, I forgot what port I'm running in. Let's go back to real quick. And I forgot the port I'm on here. Let me just grab the port settings here. 5015, okay. So if I go to 5015, I should have a breakpoint here. And we send that out, and boom. So I am debugging this. And so if we see here, if I hover over, you'll see that we're talking to the order pub subcomponent. The topic is called orders. And then we have an order model that I just passed in from the REST endpoint. And that's it. There is now a message in the topic waiting for me. So how do we get to it now, right? Well, because it's a distributed app, it's a separate process. So let's go ahead and let's just keep that running because it doesn't hurt anything. And then let's go ahead and go to the order processing service. And let's look at that really quickly and see what that looks like. So if we go to the order processing service, this is the one that's a listener. We want to wait for messages to come in, and then we want to take that message and store it somewhere. Pretty common use case for distributed platforms. They're checking message queues and saving things someplace. So if I go to my controller, this is a standard web API. This is going to look pretty similar to what you saw before, in the sense where, except, so we have our router and then we have our controller. So this is the first .NET-ism that you'll see. You see how we have that topic attribute. So we have that topic attribute. That's coming from the Dapr client runtime. So if you're in Azure Functions world, this kind of should have a similar kind of vibe with an attribute. What this is actually doing behind the scenes is it is creating an endpoint that the Dapr runtime calls back to and listens to, and then triggering this event. So this is basically a glorified event handler. But one of the nice things that .NET SDK is doing for you, it's doing that wiring plugin. But at the end of the day, if you were to look at what's going on behind the scenes here, it's a webhook. It's essentially the sidecar, the runtime, calling a REST endpoint that's passing in all the event details. And I'm not going to go into detail on this, but it's worth mentioning by default, the format of events coming in through Dapr is cloud events. So if you're not familiar with cloud events, don't worry about it. If you're familiar with cloud events, you'll know what I'm talking about. It's a standardized format for defining what goes in a message. You don't have to, you can do raw if you want to, but by default, it uses cloud events. So what'll happen here now is that this process order, it looks just like an HTTP post because it is. It's just an HTTP endpoint. It's a webhook calling back. But that's all I have to do. I don't have any complex message processing plumbing. I don't have any of this kind of stuff, right? All I have to do is have an HTTP endpoint. And I get all the information I need coming from that event. And it's worth mentioning that behind the scenes, remember all the retry stuff still applies, right? It's going to retry on failures. You can set concurrency things. You can say, okay, I only want to process one message at a time, or bring them all on. You can specify settings within the Dapr runtime to emit what your expected behavior the behavior is. It's worth mentioning, and I get this question a good bit. People ask, hey, can I do batches coming in? Batches aren't supported right now, but the batch implementation, I think, is coming out in the next release. So you'll be able to define. And the interesting thing is not all messaging platforms support batch, but this will make it appear like everything supports batch. So it does some interesting, intelligent things to do batch even when the back end doesn't support batching. But you have a lot of control over things. So let's see this in action here in a second. So let's go ahead. I have a breakpoint here. And let's go ahead and submit another. Let's go ahead and submit another one. And let's change the key on this to 7 and 24. Remember, this is just hitting, oops, that'll bomb. Remember, this is just hitting the endpoint that we already have set up. So this is hitting the original one. You've already seen this execute. Uh-oh. Did I put a breakpoint on that? I think I had a problem. Let me do this again here. May have gotten things out of order. Let me just try this again here. Can't remember if I actually launched the debugger. Try it again. Got talking and I don't remember if I hit the debugger. Okay, so, oh, there it is. I did not hit the debugger. So the breakpoint didn't get hit because the debugger wasn't running. This is the message coming in, right? And this is the message coming in. Now, what you haven't seen so far, you've seen some of the messaging pieces, but the model is coming from the body, coming in from the request. So that's the message coming to you, right? And what you haven't seen so far is saving to the state store. So this Dapr client save state, we're passing in the order model. And once again, we're grabbing the store component name that we're talking to. We need an ID. Every state store always needs to have like a unique ID. And then the body. That's all I need to do to save anything to the state store. So with literally just the Dapr runtime and a couple lines of code, we've got a distributed app going with zero dependencies on any platform outside Dapr, of course, right? So this in itself is pretty interesting, but I'm going to switch it up a little bit here. But before I do that, does this make sense? Does any questions in regards to this? Okay.
So once you, the Dapr client, underneath that YAML where you define that it was a Redis component, when you target a different environment, and say you gave it a Kafka component, your Dapr client in this code doesn't change.
Correct. Nothing changes.
Because Dapr handles the interface between both Redis and Kafka. It understands, like, if you're asking for a pub sub, that there's going to be a topic, there's going to be a topic name, and then the data on that topic.
Yep. There's a uniform pattern for all of these.
Okay.
And
that's kind of cool.
Now, it is worth mentioning, this works for like a ton of use cases. There are edge use cases where you're doing something special, right? Where it doesn't where you want to do something so special, it doesn't fit into the model. You're always going to run that anywhere, right? But you don't see it here, but I could do things like set the TTL on this if I wanted to expire. There's a bunch of other common things that you can do. Yeah, there's a bunch of different options I can do. I'm going really vanilla here on the simple side. But let's see this in action though. So let's see it. Let me show you how easy this is to change this. Now, for anybody online who wants to take a screenshot of the secret key I'm about to show, have at my environment for the next 15, 20 minutes before I kill it, right? So I've gone ahead and you notice I have a components directory under order API, right? So this is my Redis components. I have another component directory up here that contains a little bit of a different version of this. This version is order pub sub, but this is service bus. I have the state store. It's still the same name, order state store. This one's Cosmos, right? And if you notice, the metadata is a little bit different because they have different connection ways of connecting and different requirements for connection strings and this and that. So metadata is always going to be unique to the particular implementation. But as long as this is still called order state store and I don't change the root type, then we'll be good to go. It's worth mentioning, I'm not using this right now, but I just like to show this as an example. Remember those resiliency policies I was talking about? This is an example of a resiliency policy where I can basically say, here is how my timeouts will work. General timeouts are 25 second, important timeouts are 60, large response timeouts are 90. I can specify different retry policies. This is the one I want to use for pub sub. This is one I want to use, just keep on retrying forever, right? I can define circuit breakers, all those kind of things. And then I can say, apply this policy to said component. So I can say all pub subs with this name get this policy, right? So I have a lot of different options of how I want to apply policy, but I just wanted to show that real quick. Now, switching gears back to make the pull the turkey out of the oven moment work here, I need to point the component directory from my local one to the shared one. So I'm just going to cheat here real quick and go to the startup because I want to show this in debug mode here and get rid of these paths. So I don't want to use the local ones anymore. I want to use that shared one, right, that has the new connections. That's all I'm doing here, no other changes. So if I go ahead and now, and okay, we'll just leave that here. Okay. Oh, sorry. That, okay. So if we go here now and go ahead and launch this and go to the order API and launch that guy, and just so we can get it all done at once. Actually, there's a little bug here, and I think it's a little bug in the extension for the Macs, because I don't think that I had this problem at Windows. There actually is like a cleanup process that cleans up and shuts down the runtime when you stop debugging. It's like it cleans up stuff. It doesn't like doing it for me here on my Mac. So what happens is I get left with a bunch of old runtimes that aren't doing anything. They're just sitting there running, doing nothing. I don't know if that's a bug in the extension or whatever it may be, but I forgot to clean that up. So let me go back in here and relaunch that. There we go. You can see here, this is down here on the right-hand side. This is the runtime instance for Service 1. And we'll go over here, and this is the runtime instance for uh-oh. I think I'm making something mad. Let me just let the first one finish here. I'm being impatient. So just real quick here, I'm going to do a search in here and say service bus. Service, yeah. So it's trying to, you can see here in the log, you can see service bus in here. And uh-oh. We have an error. Let me see. So this is actually, I am not going to try to debug this in front of you guys right now. But this is actually what happens when, what is likely happening here is we can see here that we have a component initialization failure for order state store. So there's a problem with Cosmos, and it is trying to connect to the Cosmos DB state store, and it can't. It's timing out.
So that's a live connection.
That's a live error. I'm having a problems, whatever, for whatever reason, connecting to Cosmos right now from my desktop here. I'm not sure why, but we'll give it one more try. And then you'll just kind of have to take my word for it.
Probably a typo.
I might have a typo in there. I'll just do a quick look to make sure I didn't fat finger something on the. So the pub sub looked okay. It's the state store one that didn't look like it was happy. So, yeah, that looks happy. We'll get one more try, and if not, you'll have to take my word for it.
Name, order, states.
But let me see here. Let me. Sorry.
And then Dapr doesn't do anything to actually manage the components that they're connected to.
No.
Okay.
Yeah, that's still up to your DevOps team or
see.
whatever your team is to manage that.
We have some online questions too. In the other one.
Yeah. So let me just let me check my connectivity real quick through extensions, and then feed me some of those questions here. Let me just grab my Azure connection here.
And then Dapr is made by Microsoft, right?
I actually covered that a little bit towards the end, but it was originally developed by Microsoft. It is now a CNCF project.
Oh, okay, cool.
So it is completely independent of Microsoft now, and there's lots of different organizations contributing to it. And it has, obviously Microsoft has a good investment in it, but AWS is in there. There's a bunch of other kind of across the board. So it definitely was came to life through. See, we have orders and we have documents.
This is an interesting way to standardize.
So I do have that. So let me just try one more time here and see. It looks like I'm connecting to it, so I might have fat fingered something in here. But let's just give it one more try and make sure that I have the paths. And then if this doesn't work here, I will take some questions from the virtual audience here. Let me just grab that. So that's components. Okay, let's just give this one more try. Not sure why I'm timing out. I think I'm going to time out again. Yeah, bummer. Okay, I'm timing out. I'm not sure why. What are a couple of the questions if you have them on?
All righty, let's see. From Twitch. Assuming you set up a new Dapr thing,
Okay.
how does it interact with an existing pilot infrastructure? For example, if this is a runtime, will it expose an external HTTP API somewhere that non-Dapr people can call?
So technically speaking, you could expose that if you chose to, right?
Yeah.
The good thing about Dapr is you can pick and choose what you want to use out of it. If something in Dapr doesn't align with you, or you don't have to use state store, you can use the other pieces of Dapr. It's not all or nothing with Dapr. That's one of the nice things. We do this today, that we had some components that didn't have good alignment with some stuff we were doing in Mongo. For some use cases, we didn't use it with state store, right? So it's not an all or nothing proposition. In general, during deployment, you'll see this here in just a few minutes. This is typically targeting Kubernetes, right? That port is not exposed to anything. It's an internal container port. So it's not exposed to a service. It's not exposed anywhere. It's only intended for local host calls. So it's just between the parent container and the sidecar. Could you, if you wanted to? Sure, but you'd have to go out of your way to want to do it, mm-hmm. Which you could, right?
Yeah.
But that's not the intended deployment usage for it.
Gotcha.
Hopefully that answers the question. If that doesn't, I can
believe it
spin it
does.
away. Okay.
He chimed in.
Yeah.
Like, oh, that's right. It runs as a sidecar.
Yeah, sidecar. Yeah.
Another question. Showing the key value store as a database, quote database.
And it's good to use quotes for a key
Yeah.
value store and database.
Makes me nervous. Is Dapr state just a key value store? If so, is anyone going to use it for their database?
Okay, so I mentioned a minute ago that we don't use it for one of our use cases.
Yeah.
It's because it is really a key value for key value store use cases. Yes, you can put extraneous data in there just like you can in the body of any key value for the value, right? Mm-hmm. But if you later on want to like query that or do something else with it, there are some challenges with it. So ideally, this is key value use case. It's worth mentioning, and this is one of the things that the Dapr team, the Dapr community team, whatever you want to call it, is working on, is actually a document component, not a key value component, a document component. It's in the early formation stages, but it's intended to satisfy the second use case where I want a real database. Yeah. I want to query fields. I have index stuff. I have a query language I want to use. They're still in the formation stages of what they want that to look like. They don't want to create an ORM, mm-hmm. right? They don't want to recreate a query language, but they're still looking at that. So that is primarily the use case where I don't suggest using Dapr. If it's like your true app database, don't use Dapr for that. Use your own logic for that. If you have a key value store, caching is a primary example. We use it for caching all the time because it's nice for Redis behind the scenes. I can do whatever Postgres, so I can do caching whatever I want. When it's true key value, that's where there's good alignment. There's a middle ground, there's a gray area, yeah. Right? That you can still have success with a database. The one last thing I'll mention on it is that the problem we generally had with it is that because these go over HTTP in the middle bit, things go through JSON translation. So JSON doesn't have types, right? So weird things happen with dates, potentially unexpected because there's no date type for JSON, right? Weird things can happen there. Weird things can happen with numeric precision. Mm-hmm. So there can be some unintended consequences where I had a model and it landed in my database. I was like, what's going on there, right? So be aware of that. Do your testing on that. But hopefully that answers that question.
That's all I got.
Okay. Yes.
I have more questions.
Sure. And time check real quick.
7:18.
Okay.
But you have a couple hours. Go ahead.
Okay. That's all I need. It's Kubernetes. All I need is a couple hours. Right? No, just kidding.
So
the last little piece here that we'll show and tell here is actually the deployment of Kubernetes. That should be pretty interesting.
So you've got a sidecar running with your app.
Yes.
In a microservice environment, you've got, I don't know, like a dozen different repos. Each repo has a dozen different endpoints. Like, when you go to deploy this thing, is there a Dapr sidecar for every collection.
There's a
of
Dapr sidecar for every app,
every
every
app.
deployment, and you'll see here in a second.
Okay.
Actually, let me show you instead.
And then okay,
I'll,
yeah, show,
I'll actually show it to you, but ask your second question
And then
because it's easier to show it to you.
what is the trade-off of like latency in translating all the stuff through Dapr
So in general,
and throughput? I guess.
yeah. So in general, a couple quick things on latency and overhead. It's very common to have some sort of labor abstraction anyway, right?
Mhm.
So you're going to have natural overhead in any kind, whether you're using a library or Dapr or whatever. You're going to have some natural overhead when you have any kind of labor abstraction. That just comes with the cost. It's in our experience, it's pretty minimal. It's pretty much like using a Dapr, like an
Mhm.
ORM, that kind of DAPPER, that kind of latency. From the standpoint of local host, it's a local host call, so that really doesn't have network latency to it, but there is an overhead to a local host call.
Mhm.
But it's not really like a network hop, right?
Okay,
Where
I
it's
see.
leaving that ecosystem. The other thing is they're sensitive to that. The actual API host service is everything is Go in Dapr world. Everything's written in Go on that side, and they're using it's a specific low latency, high throughput HTTP engine for the host.
Mhm.
I think it's called like Fast or something like that. But essentially the endpoints are served with a very specialized HTTP host
Mhm.
that is intended for very specific use cases of low latency, fast, lots of small little requests. Right.
Okay.
If anybody's curious on it, I can find the link for it. I'll send it to you. It's a Go project, but it's but you're going to have some latency no matter what. But we haven't seen anything that would lead us to not say the trade-offs are worth it.
Okay.
You know what I mean?
Yeah.
But there definitely is a little bit there. Any question before I kind of jump into the second piece here? Okay. So I apologize. I really wanted to pop that turkey out of the oven and say, Shazam, look at that. We're working with Service Bus and Cosmos DB transparently. You'll just have to take my word for it that about 3 hours ago when I was sitting next to Kevin that it was all working.
Mhm.
So I'm not sure if I got some weird connectivity thing or if maybe I fat fingered a thumb into something, but something's going on. I'm not really sure what. But the concept applies. All I needed to do was translate that component and everything else works as is. But how do we get this into, what's this look like when it comes to actually deploying this to Kubernetes? So we're going to spend the last like 10 minutes here and talk through what the deployment looks like, because Kubernetes is the target deployment that most folks are deploying to. And as I'm bringing this up, the one thing I do want to mention that's worth mentioning that I don't cover today because it's a little bit of a different conversation, but it really does need to be mentioned. If you're in Azure world, look at Azure Container Apps. Azure Container Apps has native integration with Dapr. So Azure Container Apps is a PaaS platform, but it's actually Kubernetes under the scenes. So it's powered by Kubernetes, but it doesn't really expose Kubernetes to you. But it is Kubernetes behind the scenes. It has native support, built-in support for Dapr. So so even though you'll see in a second, I can't define sidecars and deploy them. When I deploy my workload to Azure Container Apps, it knows it's a Dapr, and behind the scenes, it'll take care of all the Dapr sidecars and all that kind of stuff. It's abstracted away from you, but it is a first-class experience for Dapr with one little caveat. Some of the definitions of components that I deploy through YAML, that's called a declarative deployment, where I'm doing it declaratively. You can also specify subscriptions in code. Just do it all in code. Like no YAML. I'm just going to do it all in code. There are some restrictions on the Azure Container Apps. I can't deploy certain types of components declaratively through YAML. I have to do it in code. If you got some questions on that, ping me afterwards here. I'll show you what I'm talking about. But it's just a slightly. There are some use cases that require you to write a little bit more code for things like subscriptions than I would be able to do through just a YAML deployment, right? And I think they're working on improving that experience. But there's a couple little caveats, but other than those couple of caveats, it does a really great job at providing a good experience for Dapr. So what are we going to do here real quick? We're going to deploy to Kubernetes. I've already deployed some visibility pieces because I want to see you guys see the visibility pieces. But so I've already deployed Jaeger, which is a distributed trace app for distributed tracing. I've already deployed Prometheus, which is metrics. And I've already deployed Redis. So I'm not using any of the Azure stuff for right now, just for simplicity. I'm deploying Redis. I've already deployed the Dapr controller. The Dapr controller, I've deployed it through Helm. You don't have to. That's pretty much the production go-to. But what the Dapr deploy does is it deploys an operator and it deploys something called CRDs. And essentially, those are custom definitions for components. You can register. So the component definition that you saw in YAML is a first-class experience in Kubernetes. I actually deploy that to Kubernetes. The Dapr operator tells Kubernetes what to do with it, right? But it takes care of that. It also deploys some pods. One of them is, going to your question, one of them, the important one here is the sidecar injector. So we're going to do some annotations on our deployment that's going to tell Dapr, hey, this is Dapr. This is a Dapr app. This is a Dapr container. And when it sees that, it automatically puts a sidecar in there. I don't have to do anything. It automatically wires in the sidecar, right? And so these pieces are already deployed just for simplicity, right? So I got some plumbing in there, some infrastructure in there. There's not really too much interesting to watch me deploy these. It's worth mentioning the GitHub repo that I have this in has a script to do all of this. But I don't want to sit here for 10 minutes waiting for things to happen. We're going to deploy order API and order processing. And you're going to see how sidecars and everything else work with that. So we'll go over here to Lens, which is a tool for, I wish I could zoom in on this. I apologize, I can't. You'll see here we have a Dapr demo namespace. I'm sorry, that's a Dapr system namespace. These are this, as you can see here, there's a Dapr sidecar injector here. This is, if you can't see it, trust me, it's there. It's a little small lettering. These are already deployed by the Dapr operator. So this is the Dapr infrastructure that we need on Kubernetes. It handles all the Daprisms that we're about to do. But if we go to the Dapr demo namespace, you notice I have no pods running in there. So let's go ahead and get something deployed. So if we go back to Visual Studio Code here, and if we look at my deploy folder, you'll see I have a Kubernetes folder in there. And we're going to do the app deployment. So all I'm doing here from an app deployment stage, this is just a bunch of YAML. For everybody who's familiar with Kubernetes, it's just all YAML, right? So essentially, we're defining a namespace that this is going to live in. We are defining a Dapr config. So we're saying when our Dapr apps deploy, please use this configuration. This is where you can do things like specify open telemetry endpoints, various things like that. There's a bunch of documentation on what you can put in this config. So we're going to deploy that. We're going to deploy our components. Remember these components I was just talking about? Order pub sub. That's getting deployed. It's our Redis. We're going to use Redis. We're deploying another component, the order state store. So this is the same stuff that we were running locally. We're not actually going to run it in Kubernetes. And then we have a little config map so we want to have our configuration deployed. This is basically the name of the state store, things that we were already having. Remember, I was reading from environmental variables. This is just going to make sure that those configurations are in there when the container is running. And then we have a config map for the different pieces. And then we have our deployment. This is the order API deployment. And I'm gonna skim through this real quick. And you notice I have a container here. I'm just deploying it to my local repo. Nothing fancy here. And then we have our order processing service. So these are our two deployments we're doing, one for each service. One thing I want to call out here real quick. You see these annotations right here? Mm-hmm. These annotations are the trigger for the sidecar injector. So the sidecar injector is looking for Dapr IO enabled. If it finds that, it's going to pull some of these settings. Hey, what's the app port I should listen on? Log level, there's a bunch of other things you can put on there. And it will automatically deploy the sidecar according to that desired configuration, right? And it'll automatically configure it. You'll see it here in a second. The Prometheus piece is I want Prometheus to pick up on metrics. So that's actually for the Prometheus operator. Prometheus deployment is going to look at that and say, oh, there's Prometheus metrics here. I should scrape those. So those are the annotations that we have on here. And once again, this is just normal deployment stuff. I'm talking to a container, referencing a config map, and giving it a little bit of CPU stuff. And I have some readiness ports and some best practices for a few things that don't really pertain to Dapr. So let's go ahead and run this. And let's see what we have to work with here. So I'm in a shrunk screen. I'm trying to find things here. There we go. Okay. Oops. Okay, there we go. So we're just going to do cube. There we go. So all I'm going to do is apply this to my Kubernetes deployment. I have a context here that's going to deploy the current context. And bam. Okay. So let's go back to, and I apologize. I wish I could figure out how to zoom in here, but I can't. You can see here that order API is being deployed and order processing is being deployed. If you look at that, you see we have two containers. The first container, I'm going to open up the sidecar. The first container is my order API container. This is my container I deploy with my custom code in it. And then there is the Dapr container. It's called Dapr-D. And that's a Dapr container. And you notice a Dapr container has some ports. These are not public ports. If anybody on the call is curious about that. Dapr has its own metrics endpoints. And this is a gRPC service. Remember, they talk to each other. So it has to expose its internal endpoints here to talk to each other. These aren't for outside use. But these are all the internal ports so that the sidecar can talk to the main server, right? So this is all running. And if I want to, I could actually go in here and look at my logs for Dapr-D, and I can look at see things, and I can make sure that everything's loaded. This is debug output, by the way. It normally isn't this noisy. But I can see everything that's going on with Dapr-D, with the Dapr sidecar. If your sidecar wasn't loading, it's usually because you have a component, a component misconfiguration, connection string's wrong. It's trying to spin up and it can't do that. But it does have that. So this is all I needed to do to deploy the Dapr app. I just deployed my container that automatically wired in the Dapr sidecar. Now, if we go over here and take a look at something here, let me open this back up. There is a Dapr dashboard. And I think should have on localhost 8080. So this is a little kind of a simplified Dapr dashboard. This is pointing to the Kubernetes environment. And we can see here that there's two Dapr apps, Order API, and I can actually see kind of what its configuration is and various aspects of what ports it's working on. It's not super feature rich, but it's useful to kind of get a general view of something. Now, let me run this locally here real quick. Well, I shouldn't say run it locally. Let me execute this. Let's actually run it in Kubernetes. So what I'm going to do here, and so you can see some of the visibility pieces as well, so that I get for free without having to do anything. So let me go ahead and go to our pod here, and let me go to Order API. Now this is an internal API. I can't hit this, right? This is all internal as it should be. So to kind of break that barrier, I'm going to cheat and do some port forwarding. So I'm just going to forward this on 8282 so that I then can go over to here and just change this to 8282. This is actually hitting Kubernetes, but I'm port forwarding from local to Kubernetes. That's all I'm doing. I just kind of exposed that. So let's go ahead and send this. Boom. Okay, so we can see it's processing here, right? Now, it should have already hit, because this happens super quick. It should have already been processed, and we already should have a record in there. I can check that because my endpoint here, let me see my record. My ID is 234. I have an endpoint that will look it up in our state store, and it's just using the state store API. And, oops, sorry. Use that port, 8282. Port. ID 234, right? 234.
ID and order ID. So get order.
Oh, I bet it's 57.
Or
Let me see if it's 57. I can't remember what the actual query value was going with.
is that path order ID supposed to just be ID?
Yeah, just supposed to be, and then it should be just, I think it's 234. It's supposed to be 234. Localhost 8282, right? 8282. Yeah. Okay. I'm not sure why that. Yeah, something weird's going on. But here's the interesting thing. So, well, this is actually good because if it broke, we're going to figure out why it didn't break. So remember I had said we have distributed traces and we have metrics for free. So if I go now to Jaeger, so Jaeger is a distributed trace engine, right? For distributed traces, I can visualize distributed traces. You can see I have my order API. If I want to find everything from the last 20 minutes, oh, it looks like I bet I'm failing somewhere. So, oh, no, that's a metadata call. Sorry. Let me create some traffic here. Just do a couple more calls here. New order. Let's change the IDs on stuff. 59 and let me just I'm just going to create a little bit of traffic. There we go. Okay, now let's go back to Jaeger. Okay, so now if we search Jaeger and let's go to Jaeger UI. So let's pick order API because I want to see the distributed traces there. Let's go for the last few minutes. There we go. There's one. So, okay. So this is actually some of the distributed traces coming from Dapr itself. And let's go back a couple hours here. Bye. Yeah, here we go. So we can see here that this is the distributed trace. So we can see here the order API was the first tier it hit. And that took 1.1 seconds. Then asynchronously, it dropped into the topic, got picked up by order processing, and that took 3.58 milliseconds. And then we stored in the state store over here. So this entire distributed trace hopped over 3 tiers. I didn't do anything there. I didn't do anything to write that. So this becomes infinitely useful with distributed traces, right? From the standpoint of, I was able to get a complete distributed trace without really having to do any work for it. The last piece I kind of wanted to show you here real quick was the Prometheus side. So this is Prometheus. If you're not familiar with Prometheus, it's metrics, right? I can actually go in here and see all these Dapr metrics. These are all the free metrics I'm talking about. Latencies, ingress count, state count, all these bytes received, all the things that that can help you understand the health of your services. Error rates, all those kind of things become automatic for you, right? Those are provided for by the Dapr runtime. And if you have Prometheus set up, those metrics will automatically go in there. I can pick various metrics and look at them from a graph standpoint. Obviously, I don't have a lot of data in. You can see a little bit of data there at the end, right? So this is really the kind of the story for Dapr. As we come to kind of a wrap here, let me go over some final points I wanted to make. There was a question at the beginning, and I apologize, I forgot who asked the question, but who owns Dapr? Who the creator of Dapr? Dapr actually came from a Microsoft team. Anybody familiar with, has anybody here used Service Mesh before? Ever heard of Service Mesh?
No,
I'm not Service, sorry. Service Fabric, sorry. Service Fabric, Azure Service Fabric, anybody here? Okay. It's kind of like an orchestration platform. Service Fabric actually runs a good bit of Azure behind the scenes. It's actually was open source, but kind of came out at the same time Kubernetes, and so it lost the Kubernetes the battle. But the team that actually developed that is the team that came up with Dapr. Dapr got contributed open source. It's now a CNCF project. It's actually the 9th largest CNCF project. So if you've seen the CNCF landscape, have you ever seen that landscape with hundreds and hundreds of projects? It's the 9th largest. So it's gotten a lot of uptick from the community, has tons of contributions, a lot of community activity. So it has a lot of momentum. So if you're trying to make the decision here of, it's always risky to lean into any kind of open source project, right? Oh, is it going to be here in a year? Is it going to be here in 6 months, right? In my experience, this is a pretty safe bet, right? That there's a lot of momentum behind it. It's also worth mentioning that a quick call out to Diagrid. So the team and the founders of Dapr left Microsoft, and they started. I think it's either Diagrid or Diagrid. I apologize if anybody's listening that I'm mispronouncing this. This is a startup, and it's made up of a lot of industry folks, including the founders. If you notice, there was a really weak dashboard I was showing you, that Dapr dashboard. If you really want more enterprise visibility into Dapr, when you're running Dapr at scale, you want to understand right sizing containers, control the lifecycle better. A lot of more DevOps operational tooling to support Dapr at scale. They have a pretty good product called Conductor. I don't get any kickbacks. I don't work for them. But what I like about it is that they're making their own big investment in Dapr, right? So they're not just building their products around Dapr. They're actually, in addition to a lot of community contributions, they're actually feeding into the Dapr community as well. So they're doing a lot for the community, but it's a pretty big community and it's got a lot of momentum. So where do you get started? Well, definitely check out Dapr.io. I only kind of scratched the surface here. And in a couple cases, really scratched it because the demos didn't work. But check out Dapr.io. That'll help get you started. There's a lot of getting started GitHub repo where you can run some stuff pretty quickly locally. There's a very active Discord community. So you can go on there and actively ask questions. It is really, really active. There's a lot of folks on there. They have a monthly, actually every 2-3 weeks now, I think, community call and usually has 30-40 folks on there. They're talking about what's in the pipeline. That's really interesting. And obviously Twitter and GitHub as well. And once again, feel free to reach out to me if you got some question on Dapr. Hopefully this was helpful to kind of give you an intro to Dapr and it kind of got you thinking a little bit. If you have some use cases in line, but if you ever want to talk about this or anything else, give me a ping. Always happy to chat. But thanks for having me. Appreciate it, Kevin.
Thank you. Got one more question.
Sure, fire away,
All
please.
Given what's it, Istio and Linkerd already exist, then why does Dapr exist?
Yeah, so that's a common question, and it's not an either/or proposition actually. There definitely is a little bit. There's a spectrum, and they have a crossover part, right? Istio and the service meshes in general satisfy some needs from the standpoint of service invocation and discovery. It's worth mentioning that Dapr can run on service mesh, so it's not like you have to pick one or the other. The one thing that we like that service mesh has some challenges to implement at times. It can be fairly complex depending on which one you pick, and even the simpler one, it has some complexity. You can selectively get a lot of what service mesh is doing, but for selective services without going all in on the diving. That's my first comment. The second comment is that remember Istio and service, all these platforms are service mesh. They're network-based solutions, right? So some of them, for example, can do distributed trace injections. Some of them can do some of the magic that we're having here for synchronous calls, network calls. They don't help you very much in asynchronous environments when it's not a network hop. I'm dropping something in a message queue, right? And I want to stitch that together. I want to work with, distributed app platforms. So there's definitely it's a common question. There's actually on the fact, there's actually it kind of explains it. But in general, they can both live happily together. And there are definitely stuff where Dapr isn't never intended to do stuff that service mesh does, and service mesh and Dapr can do a lot of stuff that Istio and service meshes and will never do either. So they can be friends. Kumbaya, right?
What's been what's your rollout plan been like to use Dapr?
Baby steps.
Right.
Baby steps. So I'll tell you what, without giving away too much secret sauce on things that we do at Zscaler, but I was part of a brand new greenfield platform at Zscaler. Zscaler has a lot. You're a Zscaler customer. You're probably a customer of their connectivity solutions for remote workers and remote connections and things like that. The zero trust. Yeah. I work in a very, very different unit. We do posture control. Okay. So we're about a year ago, we decided to build a whole new platform. So if I had Dapr now, if I had Dapr a year ago, from it's highly asynchronous, lots of moving parts. We have hundreds of microservices. Our Kubernetes environments are very large. I would have picked Dapr in a heartbeat. Unfortunately, at the time when we kicked off that project, Dapr 1.0 was just coming out, and it was just a little bit too the comfort factor wasn't quite there yet that it is today. So if I were to backtrack in time and Dapr were to come forward in time and we were to meet together, I would have picked this in a heartbeat on a greenfield project. But because we're not living in that world, we're doing two things. We don't want to drain the ocean. There's a bunch of things that Dapr does really well, especially PubSub. So whenever we have some new stuff coming out, we're using it for PubSub. We're not using it for some of the other moving parts. We're using it for PubSub because that's where we have some pain right now. And we're doing it in small pieces. One of the benefits of Dapr is it's not an all or none thing, right? We can decide, ironically, and I don't cover it here today, one of our first releases was a cron job piece. So think about a cron job that executes at an interval and calls an endpoint. Normally you have to do a bunch of plumbing or you got a service in there. I create a cron component and say, run this every 1 minute and 30 seconds. And it just calls my endpoint and made that kind of process easier. So little things like that were easy. We had some challenges with secrets. We're a new platform. We didn't know where we wanted to land in secrets. Should we do Kubernetes secrets? Should we do Vault? Should we do AWS Secret Store? We didn't know. This is a prime candidate for that. Like, hey, we just don't have a good secret story. Let's just use secret components for right now, right? So when I say baby steps, find good use cases that align really closely with what Dapr does well. Implement those pieces. And then what you'll find organically is that some of the extra things that maybe you didn't know about, the resiliency pieces, the concurrency controls, the free tracing, the free metrics, you just get those benefits for free, right? So some baby steps, right? Pick a pilot for it, right? It doesn't have to be super complex. It can be something as simple as a cron job, right? It's not exciting, right? But it gives you a chance to go through the exercise of deploying the Dapr operators, getting your environment ready for Dapr, and kind of figuring out the developer experience with some easy low-hanging fruit. I will say that my personal developer experience was, it's not a terrible learning curve, but there is a little one, right? There is a little bit of a learning curve here. Understanding we don't use, for example, Visual Studio Code. We're in Goland. So we ended up pretty much setting up a bunch of shell scripts that when we want to run, before we run a debugger, we hit a shell script that spins up the CLI. Not the end of the world, but it's not the F5 experience I'd like. But there is a little bit of a learning curve. So baby steps, start small, find good alignment with a use case you're having pain for right now. You'll get a good ability to get value in some of the extras that you get for free, and then just take steps from there. Is that
Makes sense.
yeah? I my days of like after 25 years, I'm more cautious than maybe I would have been 10 years ago. Right? I'm very, very sensitive to business interruption. I'm very sensitive to our teams scaling alongside our apps, and that means that our teams need time to get comfortable with the platform. And I want to de-risk things as much as possible. So that's why baby steps, give teams enough time to ramp up the developer experience, get the tooling in place, and giving your DevOps teams enough chance to, it doesn't matter, they have all these metrics, they have all these traces. If you don't have infrastructure to take distributed traces, if you don't have Prometheus set up, if you don't have Grafana dashboards, if you don't have all the things that you need to take advantage of this, this gives you an opportunity to say, okay, we need to do some of these other things first to take advantage of it. But I'm a little bit more cautious than I used to, and I think that's okay. We on our team, we balance each other out between people who are really aggressive and folks who are more cautious. We find a nice middle ground. But so far, so good. We're in our early days. We're in our early days of implementing Dapr, but it's likely going to be accelerating in the next few months as we get more comfortable with it. I would say it took us about a small team of about, we've got a couple hundred engineers, but we're just a small team that started it out, maybe like 5 engineers. And it probably took us a good 3-4 weeks to kind of get into a nice dev flow with it and get comfortable with it. And then it took us another month of nothing's perfect, right? We went, oh, we can't do that. Like the little thing I talked about with the Mongo schema things. We were all in on the state store, and then we had some data typing issues, and we had to kind of backpedal on that. So you learn a few things on that. No platform's perfect.
And these are multi-cloud deployments you're doing?
Nope, single cloud.
Okay.
We're in AWS world.
Okay.
But we are doing multiple cluster deployments because we have multiple clusters. We have multiple Kubernetes clusters.
Are you doing multi-region by any chance?
We are. We once again, I can't go into too much detail, but we have a growing global footprint.
Yeah.
You know, we have to deal with EU fund
Mm-hmm.
and soon to be Asia Pac fund.
Yep.
and obviously we already have US on. So we have a pretty big footprint.
Cool.
So any other questions? Yeah.
I believe you said that for Azure containers, you can maybe I heard wrong, but already like have a configuration for Dapr on that or something.
Azure containers. Are you talking about Azure Container Apps?
Yes.
Okay. So Azure Container Apps have some native integration with Dapr. The subtle difference is that for native Dapr, when I say native, like vanilla Dapr, we deploy a lot of our components with YAML, right?
Mm-hmm.
And those components are different types of components. Some of them are pub sub components, some of them are state store components. You can actually do subscription components. So basically, I can declaratively say, I want to wire up the subscription. And what that does is say, it tells the Dapr piece what endpoint to hit, what port to hit when it wants to talk back to your app. You can do that declaratively through YAML, or you can do it all in code. What you saw today through .NET Runtime was all in code. I just basically, I didn't show it real quick, but there's a middleware component that I said, Dapr-ize this bad boy and throw on the attributes, and it handles the registration. When the service starts up, there's actually an endpoint in the Dapr runtime that says, I want to subscribe to my subscribers. So it says on startup, it goes, okay, here's all the things I want to subscribe to, and here's where you need to send your webhooks and calls to, right? You can do that declaratively, or you can do it through code. Azure Container Apps doesn't support that through declaratively. I can't define that through a YAML, but I can define it through code, and that's what a lot of people do anyway.
So it's like maybe more secure that way.
No, I think
didn't build it yet.
it's just a different a different approach. A lot of folks like to do things declaratively. It's like, okay, how do I deploy this asset? Should I deploy it through the CLI or should I build an ARM template? It's the same kind of argument. Should I do this at runtime or should I do it declaratively? It's what they call 6.5 dozen, right? It's kind of the same thing. What I see generally is I at least in our case, we don't do declarative subscribers. We pretty much just do it in code. Once again, I'm only talking about subscribers. All the components go through YAML. I define like, hey, I'm going to talk to the state store. I'm going to talk to this pub sub. There's a specific component type that's called a subscriber. That subscription subscriber subscription, something like that, where you can define what your subscription looks like, what the endpoint is, what the port is, so that when your service starts up and registers with Dapr, it has all the information it needs to make that call back to your service. Does that help?
It's just when you use the Dapr like SDK in your app, if you're doing it mostly through code, like do you use a CLI at all to generate the YAML files or?
I'm trying to think. I don't, because generally I just copy paste from one of the other components that I've defined. I can't remember if the plugin allows you to do a scaffold.
I don't know if there's any kind of seeding with the YAML files or just scaffolding.
I think when you do when you use the extension for Visual Studio Code and you can scaffold an existing project, it'll automatically create a components folder and put some components in there. But that's kind of light scaffolding. But it'll do some stuff. But yeah, you define those through your components, usually by hand or copy paste. They're not super complex, right? And we, the key thing is you just need to make sure that your component names don't drift, or you'll be like, why isn't this working? And you'll look at the log and it'll say, oh, I can't find component A. It's because I changed the name to component B. You still have those kind of problems, right?
Yeah. If you wanted to like make a more complex sidecar, you could look at maybe the documentation on the Dapr website. So there's a configuration for the Dapr sidecar that gives you lots of different options. If you remember, there was that Dapr config YAML that I talked about. That feeds into, that's like a global configuration for Dapr within a scope, and that will seed into it. So you can take some settings from there. You can pass them in through annotations. There's a lot of different paths you can go to do that. It's also worth mentioning, and these are all very early days on a couple of these things, they're currently exploring some different ways to host Dapr sidecars. They're looking at, hey, maybe you don't need a sidecar for everything. Maybe you'll just have a pod that can act as a shared sidecar. None of that is ready for they're exploring some different deployment So
opportunities.
would a pod be less overhead than an actual?
Well, every sidecar has resources assigned to it, right?
Mhm.
That's a deal breaker for some organizations, or it appears like a deal breaker for some organizations. It shouldn't be, but it can be, because all of a sudden they're like, hey, I have 10,000 services, and now you want me to have a sidecar and those 10,000 services that each take up a little bit of memory and a little bit of CPU.
Mhm.
But in reality, what usually happens is if you have a service that's usually running XYZ, and you now want to use Dapr, what usually happens is, because XYZ is no longer running in your service, it's now running, the equivalent functionality is now running in your sidecar. What usually happens is your primary container uses less resources and your sidecar goes up. So they usually balance it out. It's a little bit of an X+1, because there's always going to be a little bit overhead on Dapr. But in general, the more the Dapr sidecar is doing for you, the less you're writing in code. So you don't need as much in your primary container because you're not doing as much. The heavy lifting is all being done in the sidecar now. So what you actually see is, if you were, let's say you were retrofitting an existing service, you had something already out there right now that was taking 100 megabytes of RAM. I'm just making that up. And it was doing everything. And now you have a sidecar. That sidecar is taking up 50. In theory, you probably will be able to drop your primary container down to 60, right? Because it just doesn't need that anymore, because it's all being done by the sidecar. And once again, those numbers are completely made up in my head right now, but just to kind of represent the fact that your workload's moving from one place to another. So it has a habit of balancing out a bit. Not quite balanced. There's a little bit of tipping there, but what we've seen is it balances out a little bit.
Mhm.
We're just doing less. You're moving your code from over here to over here. I wrote this code. Somebody else has written this code. If they're both doing the same thing, I'm just moving it's geography. I'm just moving geography is all. Any other questions or anything online, Kevin?
Nope.
Okay.
Everyone's like, we're done.
Okay. Yeah.
No more Dapr. You've blown our minds.
Okay. Well, that's good.
Even Linda, she's like, I can't listen to Josh anymore. And she's left.
Should I take that as a good thing or bad thing? It's a good thing that I even had Linda on the call.
Yeah. Well, not anymore, but
Well,
you did.
I did.
So that's
I
a
did.
plus.
It's
Yeah.
a good thing. So anyway, thank you so much. Thanks for having me.
Well, do this. Come wave at the camera.
Oh, yeah. Sorry.
So there you go.
Thanks, folks. It was fun.
Thank you, everyone online. We'll see you next month. Bye. In broadcast.